Alright, so this is Wiley question 4. This one was a little bit more straightforward. So question 4. Alright, it says propose a structure for, yeah, it's coming out clear, for an alcohol with, okay, so I'm just going to say MF for molecular formula, C5H12O. So we know this is a saturated alcohol because it follows the C, right? The CnH2n plus 2 rule. It's has no double bonds or triple bonds or aromatic rings or anything like that. Alright, so it says we need to propose a structure for an alcohol with the molecular formula of C5H12O that has, okay, so that has the proton NMR data, or they say spectrum, given below. Alright, so they want us to assign the chemical shift, right? That delta sign, the chemical shift and splitting patterns. And they also want us to eventually write the formula. So I'm just going to write out the what was on the Wiley, the graph that they had, that they gave us. So, right, the y-axis is the chemical shift in parts per million. That's the x-axis, right? And then the y-axis is number of hydrogens. So, okay, so here's the benchmark. This is chemical shift of 2. This is chemical shift of 1. So, right down here at 1, upfield, the most deshielded, there are 3 hydrogens, right? And their signal is broken up into 3 peaks. Then a little further downfield, there are 6 hydrogens, and they only have 1 peak. Further downfield, there's 2 hydrogens, and they're broken up into 1, 2, 3, 4 peaks. And then furthest downfield, which means it's closest to the oxygen, is 1 hydrogen, and it has a single peak. So the first thing that they want us to do is give the information here. And they gave us a couple set things. Remember, this is like starting at 1, this was at 2. Alright, so the table, I wrote out the table. So there was integration, which is just number of hydrogens, I guess. Then there's that chemical shift. This is how much it shifted downfield, or where its position in the graph is. And then splitting, which means the number of heterotopic carbons each of these carbons were, protons, hydrogens. The splitting, which represents the number of heterotopic protons that each of these is next to. So there's the 3H, right, which was right up here, the 3H. And the value, it's at 0.95. That's this chemical shift. And it is broken up into a triplet, which is T. The 6 hydrogens right here. are at 1.3, and the signal was split. It's a singlet. It's one peak. So the two hydrogens, which are here, the two hydrogens, the integration is two hydrogens. Their chemical shift was 1.5, and it was broken up into a quartet. 1, 2, 3, 4 peaks. And finally, the one hydrogen right here, integration 1 hydrogen, chemical shift was 2.0, and it's broken up into a singlet right there. Okay, so then now we need to write the chemical formula or structure, right? So this is what I did. I said, okay, there's one H right here. It's the most it's the farthest down. It's the farthest downfield, so it's right next to that oxygen, the electronegative. So I said this is like OH. These two hydrogens right here, they are next to 1, 2, 3, 4. They're next to 3 H's. They're next to 3 H's, which are heterotopic, which means it's not the same as them. So I wrote there must be a CH2, and right next door there's a CH3 to make that quadruple peak. Okay, so there's 6 H's. There's 6 H's, and they're not next to any hydrogens anywhere. So I said that this must be something like there must be a CH3 connected to a carbon, connected to a CH3, which is connected to a carbon, which is connected to a carbon or an oxygen. All right, that was for this, because there's no hydrogens around here that would split this. And then I have the 3H. There's a 3H that's split into 2, which means that it's next to 2 heterotopic hydrogens. So it's, I wrote something like this, CH3 to CH2, right? So with what I had, right, I have an OH, I have a CH3 to a CH2, which came from here and here. This is just, this 2 peaks is this, and this 3 hydrogens is this, right? This 3 hydrogens that split into the 3 peaks is here. Whatever, I don't want to get confusing. And then I also said for my 6 hydrogens, I have something like this. So looking with all of these in unison and saying I got to make a molecule here, and I know it's an alcohol. This is the formula I came up with, and Wiley said it was correct. Alright, we'll be posting up later, and that's it. We'll be posting this stuff later, the sheets.